Good morning, guys. Am I audible to all of you?
Yes, sir. Good morning, sir.
My
Yeah,
screen,
good morning, sir.
my
Yeah, good
screen is also visible to all of you, right?
Yes,
Yes.
sir.
Okay. So actually, I'm traveling, right? So up to 12, I will be on vacation, right? So anytime possible for me, I will take the classes. If not possible, then I will not take the classes. But once I start the regular classes from up to 12, then we will take the classes on Saturday and Sunday to cover up the missing classes, right? So no, actually, it's a festive season now, so the schools are all already closed for my children. So I have to take into them and going for some vacations, right? So hope you guys understand. Okay, so yeah, so in our last session, what we have discussed the thread class constructors, and we have discussed what are the constructor, right? Different overloaded constructor. What is thread start delegate? What is parameterized thread start delegate? Right? And when to use parameterized thread start delegate over thread start delegate? Then we came to know that using parameterized thread start delegate is bad for performance because the type is not set. Why? Because that constructor is going to operate on object data type, right? So if your function wants to take data, then you have to pass the data in the form of a object only. And you know what is the problem if you are working with object data type? What is the problem? Boxing and unboxing will come into the picture. And in our boxing and unboxing section, we have discussed how bad it from the performance point of view, right? Then we understand how to pass data to a thread function using a uh, thread function using the helper class, right? We have created one helper class, right? Within that helper class, we have provided our thread function, and by using that constructor of the helper class, we are passing the data, right? And then we discussed how to return data from a thread function by using the callback mechanism, right? Because so if you are working with the threading means you are internally working with the delegate, because whenever you are creating a thread, internally delegate is there. Delegate is responsible for executing your thread function. That is what we have discussed in our last session. And in our last session, I have shown you there are many methods and properties available in the thread class. Apart from the constructors, right? There are many properties and methods are available. Going further, we will going to cover all the important methods and properties. Today, I'm going to show you the use of three important properties. Already, I have shown you the use of one, that is sleep method. That is one of the important method of thread class. Along with sleep, I'm going to discuss two new members of thread class. One is a leaf property, and another one is join method. Right? What is the importance of join method? At what scenarios we need to use join method? What are the different overloaded version of the join method? Right? All these things we are going to discuss today. Right? And once we cover the join method, then I will discuss the use of is a leaf property, and then we will discuss thread synchronization, which is very, very important from the multi-threading point of view, right? Let us directly understand the importance of join use of join method. So you can see here I'm creating a three different method one, method two, and method three. And in this case, you can see this method one is sleep for millisecond means 3 seconds. This sleep method sleep for 200, and this thread is going to sleep for 5,000 milliseconds means 5 seconds. If you go to the definition of this thread class, guys, while I'm explaining, please try to mute yourself, right? If you go to the sleep thread class sleep method, you can see this is taking the time in milliseconds. But apart from this sleep method, there are another overloaded of the sleep method, which is taking time in time span, right? Both are going to perform the same thing. Here, you need to specify the time in milliseconds, but here we have different options. If you go to the time span class, then you can see there are many methods and many things are available, right? So you can see You can specify the number of days, number of hours, number of milliseconds, number of minutes, number of seconds, everything, right? Let me introduce to that here. Okay, let me use thread dot slave, right? And here I need to use the other overloaded version, that is the time span. And here you need to specify how many times, how many minutes, how many seconds, how many hours, right? That you want to make this thread to be sleep. So I want to sleep this thread for 2 seconds. So I'm going to use from second method, right? If you want to use from minute, 2 minutes, then you can also use from minutes. You can see from minute. If you want to use from hours, from hours, from hours, you can use from hours, right? If you want to use from days, how many days you want this thread to be sleep, then there is option called from days, right? So let me use the from hour, from seconds, right? Because I want this thread to be sleep for some seconds. How many seconds? 2 seconds. Let me use this from seconds method. But in this case, whether you want to make the thread to sleep for 1 day, 2 day, 1 hour, 2 hour, 1 minute, every time, you need to convert that time to millisecond. And once you convert that millisecond, you need to pass that value to this sleep method. So I generally prefer to this method because this, I do not need to convert the time into milliseconds. Here I can directly specify the time. So whichever option you prefer, you can use that option. But I generally prefer to use this one. So going further, right, in our session, we are going to use this time spent from milliseconds. Even you can also use this one. Is that clear?
Yes.
So this is a simple, so you can say this method is sleep for, this method means what? The thread which is going to execute this method is going to sleep for 300 milliseconds, means 3 seconds. The thread which is going to execute method 2 will sleep for 2 seconds. The thread which is going to execute this method is going to sleep for 5 seconds, right? Then what I'm trying to do is I'm creating 3 different threads. I'm creating thread 1, thread 2, thread 3. I'm creating in the sense who is creating this thread 1, thread 2, thread 3. Can anybody tell me?
Main thread.
Main thread only, because your program execution is going to start from main method, and by default inside the process there is a thread, main thread is going to start your main method execution. So main thread is going to create these 3 child threads, and then I am invoking all the child threads, and then I'm printing the main statement, right? So now let me run the application. See, so you can see here main thread started, program execution is started from the main thread, then all the child thread start execution. But this main thread, does it wait all the child thread to be completed? In this case, as shown in the output, does this main thread, what executing your main method code, does it wait all the child threads to be execute their complete their execution?
No.
Because main thread immediately completed, na, you can see main thread ended, right? We have written this console.read line. That's why we are able to see this screen, right? If you are not, if you are commenting this one, then you will see that the screen will not be visible to all, right? So as soon as your main method ends, you will see, right, completed. So in this case, we are writing this console.read line so that we can see the output. But in this case, once your main method start execution, once the main thread creates the child thread, once the child thread start executing, the main method will continue its execution, and behind the scene, the child thread are also going to continue their execution, right? So in this case, this main thread, what you have running your main method code, that main thread is not wait till the child threads are going to be completed. But in some scenario, right, in some scenario, you might be some situation where you want the child thread to be execute or complete their execution, then only you need to continue your main method execution, right? Or other, in other sense, you can say once all the child thread completes their execution, then only I need to go for the go, and then I will go and I will execute the next statement which are present here. Right? So if that is your scenario, then how you will do this? You understand what I'm trying to tell you? So in this case, I want to execute these three threads, right? Once this three thread completes its execution, then only the main thread going to execute this statement. Until and unless these three threads are not completed, I'm not going to execute this statement. Is that clear? How I can do this? Sometimes this is some scenario, na? So yesterday only in the last session, someone asked me question. This question, sir, how I can restrict this? How I can make sure once thread 1 completes its execution, then only threads 2 going to start, right? Is that possible? Yes, that is possible. Is that possible that all the child threads are going to be complete their execution first, and then only the main thread going to execute the further statement which are present there from line number 20? Yes, that is also possible. How it is possible? Now, in the thread class, there is a method called the join method. Actually, there are three different overloaded version of the join method is there. If you go to the thread class, yeah. How many overloaded version of thread join methods are there? Three methods. So this join method, what it will do is block the calling thread until the thread represented by this instance terminates while continuing to perform standard comp and send message pumping, right? So what it means, right? It means the join method would, okay, so okay, let me tell you. So how many overloaded versions are there?
3, sir.
So one is taking time in milliseconds, one is taking time in a time span, right? So both are going to be same only. What is the difference? The difference is the way you are going to represent the time. If you are using this overloaded version, the time what you want to specify, you have to convert into milliseconds. If you are using this one, right here, you can use the time span the way we are using time span, that from hour, from minute, from days, from second, from milliseconds. That way you are going to use, and this overloaded version does not take any parameter. So what they are going to do is they are going to block the calling thread, right, until and unless the child thread completes their execution, right? So in our example, if I use the join method, right, in our example, if I use the join method, then this join method will block the main thread until and unless the child thread is going to be complete their execution, right? So until and unless the child thread is, suppose I write like this, thread 1 dot join. So thread 1 dot join means what? It means now it will block the main thread. Now it will block the main thread until and unless thread 1 completes their execution. Clear or any doubt? Suppose I'm writing thread 2 dot join. Thread 2 dot join. It means what? Now it will block the main thread until thread 2 completes its execution, right? So if I'm writing thread 3 dot join, what it means? It means it will block the main thread until thread 3 completes their execution. That means once all the three threads completes their execution, then only this main method is going to be executed. Clear or still any question from anyone?
Sir, in this case, like if we write the thread one dot join, then thread one has to be completed. Till then, it will not allow anything to execute. Not even.
No, you are wrong. So in this case, so first of all, you tell me how many threads are there. In our example, how many threads are there?
One main thread, three child threads are there.
Right? So in this case, who is creating this thread 1?
Main thread.
That means this thread 1 dot join will block the main thread only. It will not block the thread 2 and the thread 3. In this case, it will block the main thread only. It will not block thread 2 and thread 3. Thread 2, see, in this case, when you invoke the start method means what? When you invoke thread1.start method means thread2.start, thread3.start means all the three threads are executing simultaneously, right? And when you write the, okay, let me comment these two statements. So in this case, this thread 1 will not block thread 2 and the thread 3. They are continue their execution the way they want supposed to be executed. In this case, this thread will only block the main thread.
Block here means, is it going to
Block means
pause?
see, block means the main thread will stop there. The main thread will stop here, right? The main thread will not continue the rest statement in this case.
Okay, so means if the main thread stop at that line, then how it is going to execute the next line? That is my doubt. Like
The
thread two dot join.
next line, see when your method, when your thread start executing. So in this case, when you call this thread 2.join, or in this case, when this you call the start method.
Okay, so to use the join, you need to use the start only.
Obviously, if you are not invoking the start method, then does your thread going to execute?
Okay, so first we need to start, then we need to make use of
Obviously,
join so that to
until
pause it. Okay.
obviously, if your thread is not executing, then what is the meaning of blocking that thread?
Okay. Got it.
Right? So in this case, your thread is executing. All the three threads are simultaneously executing, and this statement, what you have written here, it will make sure that thread 1 is completes execution. Then only it will going to check the next statement. Yes, in this statement, when it comes to this line, it will check whether thread 2 completes its execution or not. When it comes to the third statement, then again it will check whether the thread 3 completes its execution or not. If not, then wait till the thread 3 completes its execution, right? Once all the three threads are completed, then it will come and execute this step. Okay, let me run this application. All the three threads started, thread 2 ended, method 1, thread 1 ended, thread 3 ended, and then the main thread ended. See, all the three threads are started, 1, 2, 3, method 1, method 2, method 3 started. Which one end first? Which thread end first?
Thread 2.
And then thread 1, then thread 3. Why? Because if you look at the implementation, so you can see that thread 2, we have made this thread to sleep for 2 seconds. That means, and this method 1, it is the thread 1, it is going to sleep for 3 seconds, and it is going to sleep for 5 seconds. That means this method block is going to definitely execute fast. Execute all are started, but it is going to complete fast. Then only it is going to complete, and then it is completed. Right? Once all the three threads are completed, then you can see in the output the main thread is ended. Right? Clear, or still any question from anyone? Block in the sense what? Now it will not execute the further statement. But internally, once you start these three threads, right, they are going to be executed, right? These three methods are not going to be executed by the main thread. And in this statement, when you write thread1.join, it is not blocking thread 2 and thread 3. It is only blocking the main thread. And if you remove this one, then this statement means it is going to block the main thread only. So in this case, this thread 1, thread 2, thread 3.join method, they are not blocking the child threads. They are only going to block the main thread. And the main thread, you know, the main thread is going to execute your application code, main method code. Clear, or any question?
Clear.
Okay. So the first version of a join method, which does not take any parameter, right? I'm talking about this public void join, will block the calling thread, that is the parent thread, until the child thread completes its execution. In this case, the calling thread is going to wait for an indefinite time until the thread on which the join method is invoked is completed. That means what? Now, if you are using this version of the join method, then it will block the calling thread, I mean the main thread, until a indefinite time, right? Indefinite time means what? And there is no time duration. As long as your child thread is not completed, it will block your main thread. Clear? There is no time duration. So it is going to be blocked for indefinite time. Clear or still doubt? Why? How many times or how many seconds or how many minutes this thread is going, main thread is going to be blocked, or the parent thread is going to be blocked? In this case means there is no definite time. As long as your thread one not completes its execution, main method is blocked. Clear?
Sir, one doubt here, like, suppose if the main thread completes early and other threads are still running, will
Main
there
thread,
be any?
how your main thread is going to complete?
No, no, not in this case. Not in this case. Generally, I'm asking, like, not when we don't use join, the main thread is going to complete, and the other threads are still executing. Will there be any problem if we
No,
don't?
there is no problem, na? But what is there, right? They are going to be executed in the background. There is no issue at all. But in the case, if you want that your main method to be completed only once your child threads are going to complete it, then in that case, you are going to use this join method. If you want to
Okay.
make sure that this statement should be executed once all the child threads are going to be completed, then you need to use this one. If you want to if you don't want this main thread to wait until the child threads are going to be completed, then don't use this method.
Okay. Yeah. Thanks.
And this overloaded.
Sorry.
Yeah.
Sorry, one question. So you can use that, for instance, if you need a result from one of the threads. I mean, you have a callback that is going to give you the result, and you need it for the main thread.
Exactly.
Okay.
Suppose you want the response of join method, right? And then only suppose any of the thread response you want, right? Until and unless you are not getting the response from any of the thread uh, uh, um, response from the thread method, then you don't want to continue. Then in that case, you need to use this join method, right? In this case, I'm not returning any response, but in our last video, we have already discussed, right, how to return the response, right? So in that case, you need to use this join method. This join method will make sure that yes, the child thread execution completed. Then please proceed further.
Sir, can you put the thread one dot join immediately after the start? So in that case, will it wait to start the thread two also if we do
Yes.
that?
Yes. Is that what you want, right?
Yeah.
So it will block the calling thread. So in this case, it will block the main thread. Then if the main thread is blocked, then that is that line number 19 is going to execute immediately.
No.
So the same principle.
Okay.
So you can see method one, thread one start, method one, thread one ended. So thread one started, ended. Then only the thread two, thread three started because we have not put the join method, right? Then it is the normal. So the thing what I am explaining, it is applicable to each and every statement.
Okay. Okay.
Got it? Okay. So in this case, this join method will block the thread for indefinite time, right? There is no time period. As long as your child thread continue its execution, it will block the main thread. But what in the other case, right? Other case in the sense you need to specify some time period, right? If within this time period the thread execution completed, that is fine. If not completed, then please proceed and execute the rest of the code and please unblock the main thread, right? In that case, you need to use the other overloaded version, right? The second version of the join method allows us to specify the timeout. It means it will block the calling thread until the child thread terminates or the specified time elapsed. Suppose in this case, right? Suppose in this case, I specify some time slots. Okay, time span, right? Time span dot from seconds, right? So what it means if this thread, what you are calling here, if that thread is completed within the 2 minutes, right? In 1 minute, the thread execution completed. That is fine. It will proceed. In 2 minutes, the thread execution completed. It is fine, right? It will proceed. But the thread, what you are calling here, that thread is going to execute for 5 seconds. Then in that case, after 2 seconds, it will unblock the main thread and it will continue its execution. Right? After that means the number of seconds you have specified here, it will block that, it will block the parent thread for that seconds, or if the or in before okay, what time period you have specified before that time period, if your thread execution completed, then it will also unblock the thread. So here, if you are specifying the time in time, right, if within that time period if not completed, then it will unblock the thread, main thread. But before the time period, if the thread execution completed, then also it will unblock the thread and continue its execution. So here you might be have different scenarios. Scenario one, this thread one or this method one completed in 1 second. If the main thread, if the method one completed in 1 second, then it will not block the main thread for 2 seconds. Right? So method execution completed, immediately it will unblock the main thread and continue. Right? But if the method or what you are invoking using thread one take 5 seconds to complete, right? It's going to take 5 seconds. Then it will not wait for 5 seconds to unblock the main thread. As long as 2 seconds completed, it will check, yes, the thread method execution not completed. Let's unblock the main thread and continue rest of the code. Is that clear?
Okay, sir, if the time span, if it, I got confused at the first point, like if it is thread one is completing within the time that we specified in join, automatically it will release the main irrespective of the time.
Yes, it will automatically unblock
Okay.
the thread. But if we so in this case, suppose the method one what we are executing, right? If that method is going to be completed in 1 second, then it will not block the main thread for 2 seconds. In 1 second, see, there are two conditions. One is method execution completed immediately, the time span what you have specified. Before that, below that time period, if the method execution completed, then it will automatically unblock the main thread, right? And but what time period you have specified, within that time period, the method is not completed. It is taking more time, means within after that time slash, after that time period, it will unblock the main thread.
Okay, got it.
Clear? Okay, and the third overloaded version is also going to do the same thing, right? You can see, like the sleep method having two different overloaded version, the join method is also having two different overloaded version. What are these? One, you have to specify the time in milliseconds, and another one, you have to specify the time using the constant method, right? So time span class having many constant method, many static methods. Using the static method, you have to specify the time span, right? So we have already discussed this example. Now let us proceed further and try to understand a different example. So this is the same method one, method two, and method three. You can see thread sleep method I'm using. So I'm making this method one to sleep for 1 second, method two to sleep for 2 seconds, and method three to sleep for 5 seconds. So these are my three methods. So what I'm trying to do is I'm invoking this method, right? Using three different threads. And I'm using thread one dot join method, thread two dot join method. That means, so in this case, so this will block the thread until thread one completes its execution. In this case, it will block the thread two until the it will block the main thread until the thread two completes its execution. But main thread will not be blocked for thread three, right? Whether the thread three completes its execution or not, in this case, it will not block the main thread. And in this case, you can see, as soon as thread one, thread two completes their execution, it will execute the main thread. All the three threads are started. You can see method one ended, method two ended, main thread ended, then method three ended. Why? because it in this case I'm not blocking the main thread. So it is not mandatory you should write the join method on all the child thread. Whichever function you want to be completed, right, and then you want to execute the rest of the code in the main thread, you just need to invoke the join method on that particular thread only. It is not required. So in this case, my requirement is that I need to wait until the method 1 and the method 2 complete their execution. But I don't want the main thread to wait until the method 3 completes their execution. Then in that case, I can only invoke this join method on thread 1 and thread 2. I do not want to invoke this join method on thread 3. Is that clear? Guys?
Yes.
Yes.
Sir.
Okay. Now we are going to see the other overloaded versions, right? So we have discussed two different overloaded version, which is taking the time in millisecond and the time span. The same method 1, method 2, and method 3 is here, right? Right. And if you go to the join method, which is taking the time in milliseconds or time span, what is the return type?
Boolean.
Boolean means if the method execution completed, right, within the time period, it is going to return me true, right? Or as soon as the method complete or before that time period, if the method execution completed, then also it is going to return me true, right? If the time, what time period you are passing, if that is not, if the method execution not completed within that time period, then it is going to return you false. So, right? So every time you are going to use any of the inbuilt method, always try to go to the definition and try to observe what kind of method is this, right? Whether it is a static method or whether it is a non-static method, right? What are the input parameter this method is taking? What is the output of the method, right? What is the use of that output, right? Everything you can see. So return true if the thread terminated, false if the thread has not terminated after the amount of time. So terminated in the sense what? Now terminated in the sense method execution completed, right? If the method execution completed, then it is going to return me true. And if not completed, it is going to return me false. So in this case, I'm going to use from second. So what I'm trying to make sure now if this thread to method execution not completed in 3 seconds, then it is going to return me false. And then I am just printing this statement. Thread 2 execution not completed in 3 seconds. In 3 seconds or below 3 seconds execution completed, then I'm going to print this statement, right? And in this case, this main thread will block, right? Main thread will block for 3 seconds and wait thread 2 to complete its execution. Is that clear? How many minutes the main thread is going to be blocked? How many seconds? 3 seconds, right? Why? Now, because we are specifying the times span and we are specifying how many seconds to be blocked this main thread, right? Here we are specifying 3 means 3 seconds. Now here I'm going to use the join method, which is taking the time in milliseconds. So I'm passing 3000 means 3 seconds. Now again here, the main thread will block for 3 seconds and wait thread 2 to complete its execution. The same logic I have written here. Now let's see how many time this thread 2, I mean method 2 is going to take and how many minutes method 3 is going to take, right? So here you can see I'm specifying method 2 in 2 seconds and here I'm specifying 3 seconds. That means within that time period, this method 2 is going to be completed, right? Coming to this part, method 3, it is going to take at least 5 seconds to complete its execution. And what time period we are specifying here? 3 seconds. That means within these seconds, the method execution is not completed. That means in that case, this join method is going to return you true or false?
False.
False means this statement is going to be printed. And after then, the main method execution is going to be completed. But guys, this join method is only for blocking the main thread. Behind the scene, the child thread is going to be completed. The child thread execution at any scenario, the child thread execution is going to be completed. Don't think that this thread, this join method return me false means the child thread is not going to be executed, right? The child thread means child thread. The child thread execution will continue as it is. It is only related to the blocking the main thread, right? Blocking the main thread execution, right? So in this case, for this join method, right, thread 2, you will see that thread 2 execution completed. And in this case, you will see that thread 2 execution not completed in 3 seconds. Then you will see that main thread ended. And after this, then you will see that method 3, thread 3 ended, right? Let me run the application. Right, see, completed. Execute thread 3 execution completed in 3 seconds. Why? Thread 3 execution completed. Method 3, thread 3 ended. Method 3, thread 3 ended. This is 5 seconds. This is 2 seconds. This is 1 second. Thread 3 execution not completed. Some wrong output. Let me clean the solution. Let me
Sir,
run.
sorry, sir. That if bracket statement will give true or it will be false. Like, what is the this thing? If it is true, then it will execute the if thing. No, if it is not true, then it is execute false. Else
No,
condition.
it is going to return me false. Now, thread 3 execution completed in 3 seconds.
Then it will execute else part.
Yeah, it should execute this else part, but why it is thread 3, method 3? Okay, let me increase the time period. I don't know why it is giving me like this. So this is thread 1, thread 2, thread 3. All the threads are started, or yeah, that is fine. Thread 2 join from seconds. Thread 3 join milliseconds. Thread 3 execution completed. Hmm. Now I don't know why I'm getting that wrong output previously, but now you can see, right? So now you can see thread 2 execution completed in 3 seconds. Thread 3 execution not completed in 3 seconds. Then main thread ended. After main thread, method 3 or thread 3 is going to be ended. Is that clear? Clear or not?
So these blocks, the main thread will going to execute after it the threads releases the main
Exactly.
thread. Okay, that is
Exactly.
why it is printing at the last.
Exactly.
Okay.
So in this case, we have written this statement after this block, this thread to join method, right? That means once the main thread is released, right, then these statements are going to be executed. So in this case, it will, so once this statement is executed, so, okay, coming to this, once this line number 21 is executed means your main thread is blocked. Until and unless your main thread is not released, right, the statement, further statement is not going to be executed, right? So how many milliseconds the main thread is going to be blocked? Here 3 seconds, 3 seconds, or less than 3 seconds. If in less than 3 seconds the method 2 is going to be completed, right? And then in this case, once this line number 31 is executed, right, so it will block the main thread again for 3 seconds, or less than 3 seconds if the thread, or if the method 3 is going to be completed in less than 3 seconds time, right? And in 3 seconds, if the method execution not completed means this join method is going to return you false, and in that case the else statement is going to be executed, then this statement is going to be executed. right? And once all these things are completed, then we cannot predict when this method 3 is going to be completed, right? That is going to be executed by a separate thread. Clear? Or any question from anyone? Guys, any question from anyone?
Sir, I have one question.
Uh,
Like how we are right now blocking the main thread.
yes.
So similar way, like within the child thread, can we do this
Yes.
implementation?
Exactly. Within the child thread, you can create further threads. You can block those threads. The same concept. Here, in this case, your main thread is creating this child thread, right? And if
Yeah.
you create some method here, right?
Mhm.
If you are invoking some method from method one, right? Then those methods are going to be created by the child thread, right? So in that case, if you invoke the block method, then the thread one is going to be blocked, and the thread one is going to be blocked means your main thread is also going to be blocked.
No, sir. My question is like once thread one is running,
Yes.
and until it will complete, I don't want to run the thread 2 and thread 3. So can we implement this type of scenario?
Yeah. So that is what I'm showing now. So you just need to invoke the join method here, na? Thread one dot join method. So thread one
Okay.
dot join method means what? It will block the main thread here. It will block the main thread means what? This thread 2 and thread 3, this two statement what you have written here is never going to be executed, right? And as
Okay.
long as these two statements are not executed means they are not started.
Okay, sir. Got it. Thank you.
Yeah. Any question from anyone else?
So in real-time scenario, like how we use this join, like you after every thread start we use join, or after all the thread got started we use this join.
So you cannot predict that after all the thread or after one thread, right? So it's basically depend on your business requirement. Like the way, say in this case, you can see, I'm for my business requirement, I don't want this main method to be blocked for right main method to block for thread one. I'm not using join method on thread one. I want this. I want to keep 2 second time slash or time period to this thread two. I want to give 3 seconds time period to this thread tree, right? So in that case, see, it's completely based on your scenarios, right? How many times you want to block the main thread and how many seconds you want to provide the child thread to be completed. If not completed, you need to continue your execution, right? It's completely based on your scenarios. You cannot predict or you cannot blindly use this join method on each thread. It's going to it's like basically a scenario based implementation. So based on your business scenario, you need to implement this one. And coming to your point, nowadays people are not using this threading concept, right? People are mostly using a task, right? Task based asynchronous programming, right? Parallel programming. Because task, if you want to understand task, you need to understand this threading concept. Because task is, if you are not aware, if you heard the two keyword async and await, then you might know they are only implementing, simplifying the use of this threading concept, right? So it's basically completely your scenario based implementation, right? And mostly if you are going to execute thread, then why you are going to block the thread, right? If you are, say in this case, if I want to use if I want to invoke this thread one dot join here, right? Thread one dot join here, then first of all, why I'm going to execute this main method one using threading concept? Because if you are using threading means some time period it is also going to take to create the thread, to create the delegate instance, right? To invoke the delegate instance, that delegate instance is going to invoke your method. This is also going to take some time, na? If you want to make sure that this method execution completed, then only I need to continue my main thread execution. Then better execute this method in a normal manner only. Why I'm going to do all such things, right? I can directly invoke this method one here. So instead of doing these two statements, right, what I can do is I can simply invoke the method one like this. That is also fine for me. So in this case, this method one is going to, okay, now tell me this method one is going to be executed by which thread?
Main thread.
Obviously main thread. Main thread means it's a sequential order execution or not. Until and unless this method one not completed, these two statements is not going to be executed. So why we are using threading means for simultaneously executing multiple methods, right? In this case, if method one is blocked for 10 seconds, right? Right, if it is taking 10 seconds, or if it is doing some kind of a database call, some kind of a API call, right? Then in that case, these two threads are also going to be shift idea, right? These two methods are not going to be executed, right? So that is the scenario. If you want to use, if you want that once this method execution completed, then I'm going to execute rest method, and it's a sequential execution. In that case, no need of a threading concept. Is that clear?
Yes, yes, got it.
Right? So threading means you want to execute multiple things parallelly. Yes, sometimes we need to make sure that one of the thread execution is completed. Then only I need to proceed further. Then in that case, you need to use join method. For example, in this case, I want to start all these three methods simultaneously. But once this method three completed, then I need to proceed further. Then in that case, you need to use join method. Right? So this is how you are going to use join method, and I hope you understand the three overloaded version of the join method, when to use and how to use. Clear, guys?
Yes.
And we have already discussed the sleep method, right? Both the sleep method we have discussed. What is the difference between them? How to use them, right? This will take time span, and it will take time in milliseconds. And apart from this, there is a property called IsAlive. That is what we are going to discuss. So gets a value indicating the execution status of the current thread, right? And it will return true if this thread has been started and not terminated normally or aborted, right? That means if you create one thread, right? So if you create this thread one, and if you have not started that thread, means the status of this thread is unstarted. And once you invoke the start method, means the thread is started and its status is going to be running state. And once the thread completes its execution, then it is going to be the status as terminated, right? And this is a live property. What I'm showing here is, if the thread is in running state, then it is going to return you true. Otherwise, any other state, unstarted, right? Terminated either normally or aborted, right? It is going to return you false. Okay, let us understand this with an example. So this is not that important. Just for your understanding, I'm showing you one example. So this is my thread one, right? And thread one, and this thread is started, and I'm checking whether the thread is still executing or not. If the thread is still executing, it is returning me true. And in that case, I can check, print some message, and I can display, yes, the thread is still executing. And once the thread execution completed, then you can display this method, right? Okay, so what I can do is, okay, or I equals to, okay, I less than 1000, right? So what I can do is, I can put all this code inside a for loop, right? Thread one still executing, completed, and here I can write the break statement, right? So in this case, right? So in this case, what I'm trying to do is, I'm making this thread to sleep for 10 seconds, right? So you will see that not 10 seconds. Let me put this inside 3 seconds. Okay, now let me run the application. Okay, let me do in another way. Let me use the sleep method thread dot sleep. Which version I'm going to use? The time span dot from seconds. How many seconds? 1 second to make this thread sleep. And here this thread is going to take 5 seconds to complete. Right. So in this case, let me run the application. Main thread started. Thread one method is still executing. Thread one method one is still executing. Yeah, thread one method completed its task and main thread ended, right? So you can see method one once completed, then it is going to return me false. In that case, I'm printing this statement, right? As soon as the thread is executing, it is going to return me true, right? As soon as the thread completes its execution, it is returning me false. And in that case, you can see the statement what I have written here, it is going to return me, it is going to print that statement. So basically, this IsAlive means what? Now, as long as your thread is executing, that means as long as the status of the thread is running. So what are the different status? We'll discuss later, right? Later in the sense, once we start discussing our concept called thread lifecycle, at the time I will explain you. But for now, you just remember the thread is executing means the status is running. As soon as the status of the thread is running, it is this IsAlive property is going to return me true, right? And if you want to implement such kind of a scenario, right? Suppose you are making some database call or you are making some API call and you want to print this type of message. Your execution is going on, processing, right? Then in that sense, you can use this IsAlive property. And once your processing is going on, you can display one message like this. And once the execution completed, then you can print like this, right? So this is not that important property, but yes, this property is there, which is going to return you true as long as your thread is running. And once the thread is completed, then it is going to return you false, right? Clear, guys? Guys?
Yes, sir.
Okay. So this is not that important. Now we are going to discuss one of the important concepts, that is thread synchronization. This is important because if you are working with multi-threading and if you do not know what is thread synchronization, then it will be very difficult to understand the rest of the concept, right? So what is thread synchronization? What are the problem if you are not following the thread synchronization, right? And how to implement thread synchronization? That is what we are going to discuss now. See, data inconsistency occurs when more than one thread access a shared resource such as in-memory data, or like instance of class variables, right? Or you can say methods, methods, external objects such as a file assignment. What it means? It means suppose you have one shared resource, right? Suppose you have one shared resource, right? Suppose you have one shared resource, right? And you have two threads, thread one and the thread two, right? Suppose thread one execute this resource, right? He updates the data. Okay, thread one, okay, let me give you in that way. Some variable is there. Some variable one is there, right? And this thread one read the value as 10. Thread two also read the value as 10. Yes or no? And he is doing some modification. He is updating the value to 7, and thread 2 is also updating the value to 8. That means in that case, he wants to reduce the value by 3, so the output should be 7, and he wants to reduce the value to 2. That means the output, the expected value should be 5. But in this case, he read the value 10. This thread 2 also read the value as 10 because by default, the shared variable value is 10, right? And then thread 1 try to reduce something, right? So in this case, you can consider this is the number of a ticket. Suppose you are implementing an application for movie booking, right? So the number of available ticket is 10. And in this case, thread 1 booking 3 tickets, thread 2 booking 2 tickets. And both the thread are executing simultaneously, means they are reading the value as 10. As both are reading the value as 10, after 3 ticket bookings, they update the value as 3. And this thread, after booking 2 tickets, he also read the same value. So he is updating the value as 8. But what should be the actual value? What should be the actual
5.
value? 5. But
Five.
what value we are getting in this variable? What value we are getting in this variable? 8. That means there is some data inconsistency or not?
Yes.
So I will show this practically, don't worry. So what it means, data inconsistency occurs whenever multiple threads trying to access the shared resources. That resource may be a method, may be a variable, right? May be an external file. External file in the sense, suppose you have one text file. Thread 1 trying to update some data, right? Update the file, and at the same time, thread 2 is also going and updating the file. That means 2 threads updating the file means at simultaneous means we have data inconsistency, right? So we need to handle this scenario. If we are not handling data inconsistency, then we will face the problem, right? Okay, let me show you one example. Without using without implementing thread synchronization, then I will make you understand how to implement thread synchronization. So in this case, this is my shared resource. So in this case, the shared resource is a method, right? This is my shared resource, and this is my shared resource in one method. Now, so I'm creating 3 different threads. The name of this thread is thread 1. Thread name of this thread is thread 2, and the name of this thread is thread 3. So why I'm accessing this name property means, if you go to the definition of thread class, you will see that name is a property, right? So name is a property which is having both setter and get accessor. So as it is having set accessor, so while creating the instance, any property is there, you can any setter and getter priority, you can say set and get accessor, right? So you can also set the priority of the thread, right? While you are creating the thread class instance, that we will discuss later. So currently I'm just using this name property. If you don't like this option, then you can use this option also. You can also use this option also. That is also fine, right? So in this case, I'm creating an instance and then I'm setting the value. But as soon as I do this thing, 2 statements, I'm getting one warning. What you can see one event I'm getting bulb type. So this is nothing but one event. And if you click on this, it is an object initialization can be simplified. How? Just click and this thing. So instead of creating 2 different steps, so you can do like this. Then I'm invoking the 3 methods simultaneously, right? So I'm starting the thread 1, starting the thread 2, and starting the thread 3. That means now all these 3 threads trying to access the same resource or not? Yes or no? Guys,
Yes, yes, yes.
previously what we saw that each thread is trying to execute a different method. But in this case, I'm creating 3 threads, and all these 3 threads are trying to access different method or one method. So if one method is accessed by multiple thread, then that method is nothing but a shared method. This method is going to be shared by multiple thread. And whenever multiple thread trying to access some shared resource, right? So you can say it's a resource. Everything you can consider as resource. If you are creating a variable, if you are creating a method, right? If you are creating an instance, everything is nothing but one resource, right? So if you are invoking this shared resource by using multiple thread, then we may not get the data as expected, right? So in this case, what should be the data? So it should print like this: welcome to .NET world. Welcome to the .NET world. But now if I execute this program, then you will see the unexpected output. You will see the unexpected output. See, welcome to the .NET world, and the .NET world, right? So this is the output. Are you expecting? We do not want this output. What we want to welcome to .NET world in 3 different lines. We do not want the output like this. Welcome to the .NET world of .NET. I don't want the output like this. How I want the output like this. Welcome to the .NET world in all these 3 lines. And why I'm getting this issue, right? Why I'm getting this inconsistent output, or why the behavior is changed? Because this shared resource is going to be, right? This is my shared resource, and this shared resource is going to be accessed by 3 different threads. And whenever you are accessing the shared resource, and if you are not protecting that resource, then that resource is going to be like this. Anyone can use it, right? Suppose you are creating one bike, right? And if you make that bike as a public, and if you make that bike as public, and if you say anybody can use, then anybody is going to use that bike or not? That means you need to provide some kind of a restriction. Yes, this is my bike, but this bike is going to be used by me, or by my friend, or by someone else, but not everyone, right? We need to protect the shared resources. Shared resources is meant to be used by multiple people, but there should be some protection. Protection in the sense, at the same time, 2% cannot use my bike, right? So this is where you need to use thread synchronization, right? So in this case, without thread synchronization, the output or behavior is going to be this. So thread synchronization means what? Now, so the thread synchronization means protecting your critical section code of your application. So in this case, this is my critical section code, right? And I don't want multiple thread to access this critical section code simultaneously, right? As long as one thread enter into this critical section, then until and unless he is not completed its execution, no more thread can enter into this section, or no more thread can enter into the critical section, or no more thread can going to execute this 3 pieces of code. Right? So that means what? Now, it means by using thread synchronization techniques, we will make sure that our shared resources, see, in this case, you can use the term thread shared resources. You can also use the term critical section code of your application, right? So this is nothing but the critical section code. And thread synchronization will make sure that this critical section code is not going to be executed simultaneously by multiple threads, right? Currently, why we are getting this output means this this code is going to be executed simultaneously by 3 different threads. Thread 1 start, so it is going to execute this code. Then thread 1 is going for sleep. Thread 2 start, also it is going to execute this code. Then thread 2 going for the sleep. Thread 3 start, he is also going to execute this code, and then he is going to sleep, right? And again, once they wake up, then again they are going to execute this record. So what we are going to do is, we will make sure once thread 1 enter into this section, right? Once thread 1 execute this code, right, from line number 35 to 37, until and unless this 3 line of a code not completed, not completed, right? Execution not completed, thread 2 or thread 3 cannot enter into this section, right? So this is nothing but your thread synchronization. How to implement this? There are multiple mechanisms available, right? You can use monitor class, semaphore class, locking mechanism, semaphore stream, right? Many options are available, and those options we are going to discuss, right, one by one from our next session. But now I'm going to show you one of the most useful option, right? That is locking. So you understand what is exactly the issue without thread synchronization, guys? The output or the behavior is going to be changed completely. You cannot have a control over what should be the output. But if
Yes.
you use thread synchronization, then you have control. So whenever I'm using thread synchronization, you need to understand one term, right? One term means what? A critical section, right? Critical section means the section which is very, very important, the section which you do not want multiple threads to execute simultaneously. That section of code is nothing but your critical section. Then what we need to do is we need this, once the thread one start its execution, then thread one needs to acquire a log. Then thread one needs to log these three statements. Once thread one acquire a log on these three statements, then no other thread can enter into this section until and unless thread one release the log. That means what we need to do? We need to implement some kind of a locking mechanism, right? So we need to log start, right? We need to start the log here, and we need to release the log. Release log. That means what? Now start log and release log, right? So once thread one or thread two or thread two, whichever the thread executing this method, that thread will acquire a lock on this three statement. Once that thread acquire a lock on this three statement, then no other thread can acquire a lock on this three statement. Once suppose thread one comes, right? Suppose thread one comes. Suppose thread one comes, then thread one will acquire a lock on this three statement. So once thread one acquire a lock on this three statement, then thread two cannot acquire a lock on this statement, or thread three cannot acquire a lock on this three statement, right? Once thread one release the lock, means once these three statements are executed by thread one, then only thread two or thread three is going to acquire a lock on this statement. How we can implement this, or how we are going to do this? There are many options available to implement this locking mechanism, or there are many options available to implement thread synchronization, like you can use log object, you can use semaphore, monitor, semaphore slim, right? Many options, all the options we are going to discuss. For now, I'm going to use one of the simplest option, right? Static object. I'm creating a variable called the log object, initializing this variable using new object. So this is a variable, right? So I'm creating a string of I'm creating a variable of object type. I'm providing that name as log object, right? So what you need to do is you simply use the log keyword, and to this log keyword you need to provide this log object, and then you have to write your critical section code within that log object, right? So now this log object, this is your log object, is logged by it's logged using this log keyword. That means what? Now any thread we enter into this sum method, they will acquire a log on this block. So this is nothing but your log block, right? What it means, so as soon as this block is executed by one thread, no other thread can come and enter into inside this block. Any other statement you can write here, right? So console dot write line, right? So you can write here. So how to get the name of the thread? Can anybody tell me? Thread dot, there is a current thread dot name property. Trying to acquire a log, right? Trying to acquire a log. Then what I'm going to do is I'm writing the same statement, thread log, get the log. Release the log. So what it will happen? So so in this case, this statement what you have written here, right? All these statements are going to be your log, right? All these statements are nothing but your critical section code. This statement cannot be executed simultaneously by multiple threads. One thread execution start, right? That thread execution end, then only other thread trying to or coming and execute this. But this statement what you have written, Is that statement as part of your lock object? Guys,
No.
that means this statement can be executed simultaneously by all the threads. But this statement, what you have written using the log, means it will log this block. Log this blocks means one thread only execute this statement at any given point of time. Once that thread completely execute all this code block, then only other thread is going to execute this statement, right? Now, if I run the application, then you will get a better idea. See, so thread 2 trying to acquire a log, thread 2 gets the log. Welcome to the thread 1. Okay, so we are getting different output. Why, you know? Okay, let me comment this statement because the output is not that great, right? See, so thread 1 gets the log. Welcome to the .NET world. Thread 1 release the log. Once thread 1 release the log, then only thread 2 gets the log. Thread 2 execute the statement. Thread 2 release the log. Then thread 2 gets the log. Why I'm getting the same name? Did we miss anything? Yes. Here we have written thread 2. It should be thread 3. Thread. Now you will see that at any given point of time, the log block is going to be executed by only one thread, right? So you can see thread 1 gets the log, thread 1 release the log. Then only thread 2 gets the log, thread 2 release the log. Then only thread 3 gets the log and thread 3 release the log. Is that clear?
Yes.
Now at any given point of time, you will see that this code block, what you have written inside the log object, it is not going to be shared by multiple thread, right? It is shared by multiple thread, but at any given point of time, only one thread acquire a lock on that critical section. Once that thread completes the execution, right, then only other thread is going to acquire a lock. More than one thread at the same time, they cannot acquire a lock on this object. If they want, they have to wait, right? And they have to wait till the other thread, which is currently executing the lock of block, once they release the lock, then only the other thread which they are in the waiting list, they will acquire a lock on that critical section. Is that clear, guys?
Yes.
Okay. So this is nothing but how to implement thread synchronization. So using this lock object, we are implementing. So first of all, you need to create a variable of object type, and then you just need to pass that variable to this lock. So currently this lock will lock this object, right? And the code you have written inside this block is going to be locked. Locked means the thread or at the thread which is currently executing, you will acquire a lock. He will only execute the on this code block, and once he release the lock, then other thread can come and execute the code. Is that clear?
So, here, like creating the lock object, how it'll the system identifies that it'll
So
get locked.
this is the mechanism now. So thread synchronization means this is a keyword, right? This is a keyword. This keyword is provided by Microsoft. If you want to lock any critical section code, then you have to use this lock keyword. So this is a keyword. But see the how you are going to create the try catch block. Does .NET Framework provide you some keyword to implement a try catch?
Yes, internally.
Yeah, the try is there, catch is there, right? If you want to write some code which is going to throw some exception, then you have to write those code inside the try block only. Similarly, if you want to make sure that only one thread is going to execute some code, right, then you have to write those code inside the lock block only. Clear?
Yeah. So this lock object, what you are passing here.
This is lock object means it's just a variable what I'm creating. So here you just need to pass a string one object, right? So this means see This means it will lock this object, right? This object means what? And this is the object which is not going to be shared by multiple threads at the same time, right? So it is just making sure that this object is locked, and the code what you have written inside this block, see what it means. Now acquiring a lock, right? So if you, I do not know, I don't know whether you have operating system concept in your academic or not. There is a concept called a deadlock, right? You know deadlock?
Yes.
So deadlock means what? Now one thread
Like,
acquire a lock on one resource and waiting for another resource, right? Whereas another thread acquire a lock on the one resource and waiting for another resource, which is already locked by different threads. So in this case, this lock object, this lock means this thread lock this resource, right? That means this resource is not going to be shared by other thread until and unless this resource is released. And as part of this lock block, you have to you have to write your critical section code, right? The code which you do not want to be executed simultaneously by multiple threads. So once a thread acquire a lock on this lock object, then this lock block, right? What you are writing here is not going to be shared. So this is
so,
nothing but acquiring a lock on object.
so this lock object is what? So like those threads are using this object, was using this object previously, or like what is this object is used for?
So this is just a variable now. A lock object you can give anything. So currently I'm going to give you a different name. So basically, okay. So let me. I'm just giving some lock one or underscore log. So any name you can give, right? So I'm giving underscore log. So basically what? Now the thread acquire to see there are two kind of logging. One is a exclusive log and another is inclusive log, right? So in this case, this is an exclusive log, right? So in this case, you need to see whenever I'm executing some. So suppose see, uh, suppose there is a toilet, right? There is a toilet. At any given point of time, how many people can enter inside the toilet?
Only
Only
one
one,
person.
right? But once you are entering inside the toilet, then you need to close the door or not.
Okay, it acts
So
like
that,
the
yeah,
key or
it's like
something.
a key. So once you close the lock, means this window is this door is closed. Now no one can enter inside this door. So the same thing is here. So we are
Okay.
just locking this code block by using this one. So this is nothing but it's a key, and you
So,
are locking this key so that no one can enter inside the room. You can see.
okay, so thread will not have any access over the log once the system automatically once it is shared to or some thread is accessing it, enters it, it will lock it unless
Yes,
the thread is going out of that
exactly,
loop.
exactly,
So after
exactly. So
that only it will release that lock so
yeah,
that
so
another control can
exactly.
enter. Okay.
Exactly. So in this statement, when the close curly braces is executed, that means the window is open, right? The door is open, then another person can enter inside the. Understand?
Yeah, yeah, got it.
Okay. Now we are going to discuss one real-time example so that you will get better idea. Right. First of all, I will show you the example without using that locking or without using that concept called show method. Why it is coming? Right. So first of all, I will show the example without using thread synchronization. Then I will show you the problem. Then I will show you how to remove or how to solve the problem. So basically, you can see this is my class book, my show. Currently, let's assume that the number of tickets available is 3. And here I'm creating some static variable I, j, k. So you can see I equals to 2, j equals to I equals to 1, j equals to 2, and k equals to 3. That means what my intention is, three threads are going to book ticket. One thread will pass the number of tickets to be booked as 1. Another thread is going to pass the number of tickets to be booked as 3. Another thread is going to pass the number of tickets to be booked as 3. That means 3 threads trying to book 6 tickets, but the number of available tickets is 3. That means either these two is going to be success or this one is going to be success. But all of the threads should not book the ticket, right? So in this case, you can see this is my book ticket method, right? And in this method, what I'm trying to pass, I'm passing the thread name who is currently calling this book ticket method and how many number of tickets he wants to book, right? So what I'm checking the wanted tickets, the number of tickets to be booked should be less than or equals to the available tickets. And if this condition is satisfied, then I'm just printing this number of tickets booked by this booked by, right, this thread, right? And then what I'm trying to do, I'm just making this deduction, the number of tickets available, I'm just deducting or subtracting from this wanted tickets. And if the number of tickets you want to book is not is less than or available or greater than this condition, right? Suppose you are trying to book 3 tickets and the number of available tickets is 1, then in that case the condition is going to return you false, and in that case the else block code is going to be executed, and in that case it will give one message, no tickets available to book. Any question related to this business logic? It's a simple logic.
No, straightforward.
It's a straightforward logic, right? And this ticket booking means now, right, this is the method which is going to be invoked by 3 different threads, right? If the thread 1, if the name of the thread is thread 1, then I'm calling this book ticket method, right, by passing the I value. What is the I value here? I value is 1. So instead of I, so what you can also do, let me remove these things here, right? Let me comment this one. I'm passing 1, I'm passing here 2, and I'm passing here 3, right? So basically, once this method is going to be invoked by 3 different threads, and if the thread is if the thread name is thread 1, then he is trying to book 1 ticket. If the thread name is thread 2, he is going to book 2 ticket, and other thread means in this case the thread 3, then he is going to book 3 tickets, right? And now from our main method, what I'm trying to create, I'm creating the book my show instance, because this is a non-static method. So you have to specify by using the instance of the class. So I'm creating book my show, and in this case, I'm calling the ticket booking method. And here I'm specifying the name of the thread as thread 1. Here I'm specifying the name of the thread as thread 2. And here I'm specifying the name of the thread as thread 3. And I'm invoking all the 3 threads, right? So now let me run the application and show you the output. So see, what is the problem? Can anybody tell me? As this is nothing but my critical section code. Yes or no? This is my critical section code or not? The actual booking is performed by this if else condition. As this critical section is not protected. So what is the problem? The problem is all the 3 threads can access this code simultaneously. One thread access this code and he checked that the number of available ticket is 3. Yes, condition satisfied. For thread 2, the same condition. For thread 3, the same condition. For all the 3 conditions, for all the 3 threads, this condition is satisfied. Why? Because all the 3 threads simultaneously access this code block, right? As we are not protecting this application, or as we are not protecting this shared block, right? So we are getting some inconsistent output. Here the output is inconsistent or not? The number of available ticket is 3.
Only 3.
You are able to book 6 tickets. Is that possible in real time?
No, not possible.
Not possible. Then what we need to do? Then we need to make sure this is my critical section code, and this section of code should not be accessed simultaneously by all the 3 different threads. This code block should be accessed by only one thread at any given particular of time. So what you need to do? So what you need to do means you need to create one lock object. So how you are going to create? Suppose I'm creating one static object, You can give any name. I'm providing log object, right? And I'm providing this name as new object, right? So then what you need to do is you need to use the log functionality. And within that log functionality, you need to write your critical section code, which you do not want to be executed simultaneously by multiple threads. So in that case, I'm putting this code block, right? With this implementation, now your critical section code, or you can say book ticket, is protected. Protected means no more one thread can access this code block simultaneously. So in this case, if you are protecting this, suppose one thread completes this execution, means this variable is going to be updated, and when a new thread comes, then you will get the updated data, right? So in this case, now run the application and you will see that only 3 tickets are going to be booked, and see 3 booked by thread 3, no tickets available. Right now, if we run on the application again, you will get a different output. So you cannot predict the output, but what you can predict, maximum 3 tickets you can book, no more 3 tickets can book by this application, right? So if you are implementing some kind of application like this, where you are providing the user to book the ticket, then you need to make sure that the implementation, which is therefore booking the ticket, should be protected. Because if you are running your web application, then at the same time 5-10 people can click on the book ticket option, right? But in that time, you do not want to book the number of tickets, right? So you have to provide implementation like this. Now you are getting the output as expected or not?
I have one question.
Yeah.
See, can't we impose first in, first out kind of logic here?
So if you want to input first in, first out, then this is going to be your, so can you predict which thread is going to execute first?
No, as per the output, no, because each time you're getting different
Different output.
output. Yeah.
And which thread you want to execute first?
I want to execute first thread. First thread, thread 1.
First thread you want to execute first,
Yes.
then second thread, then third thread.
Yeah,
But,
in that chronological order.
Yeah, but is that in your is that control on your hand? Who is creating?
Right now, it is not. Right now, it is not.
Right. So this is the reason we cannot predict, right? So there is a concept called thread priority, right? At that time, I will show you how to set the priority of a thread, right? But currently, I don't think that will work, right? So,
Okay.
right. So, but for deadlock scenario, you need to set the priority so that that thread is not going to be your victim thread, right? But currently, you cannot predict it. This is not on your hand, right? So you cannot decide how many times we need to keep for thread 1, how many seconds we need to give to thread 2 for execution. That is completely controlled by the operating system only.
Okay.
Right. But in this case, it will make sure that, see, in this case, only the first in, first out principle is applicable. Whichever thread come into this, now whichever thread execute this book ticket first, that will get the option to book the ticket, right? But we cannot predict which thread is going to execute first, right? So they are the operating system will decide which one is going to execute first for how many seconds, right? That will be decided by the operating system, right? So
But on what criteria does the operating system decide? What criteria?
But at what criteria, even I do not have that idea, based on the what condition, based on the what scenarios, right? What are the things he is taking into considerations, right? I do not have any idea related to this, but yes, while we are going to discuss deadlock, right? At that time, I will explain you at what condition, at what criteria the operating system will choose the victim thread. But while calling the method, I do not have any idea, because all the threads are going to be same only. And all these threads are going to execute the same method. I cannot decide which method, which thread is going to execute first, right? But for the deadlock scenario, I can give you some clarity at what scenario, at what condition he is choosing the victim thread. But for this one, I do not have any idea. Even I never tried to do some kind of R&Ds at what scenario or how the operating system choose which thread to execute what. If you are having any idea, or if anyone having any idea, then they can put the thing on the group so that we can go through it and we can check it. Right?
Okay.
Let's do a R&D on this. Let's try to observe how the operating system choose which threads to execute first. Right?
Yeah, sure.
Yeah.
So,
So it's not for me. I will also do the same thing. I will do the R&Ds. The condition that operating system to select the threads which are going to be executed first. It is a task for all of us, not only for me. Even it is a task for you also, guys. Right? You also just try to figure out the condition how the operating system choose the thread, which threads to execute first, which thread to execute second. How what are the condition? There should be some condition, right? Based on the condition, is only going to choose the threads, or it choose randomly. That what we need to understand, right? So any question from anyone related to this example?
Yes, sir, one small doubt. Like you were declaring that log object, no? So you were declaring it as static. Is there any reason when declaring as static?
Static, yeah, I'm declaring this as static because I can access this variable directly. If I declare this as a non-static, then also I can use this. There is no issue. Why I'm declaring this as static means this variable is going to be created only once during the life cycle of this. But if I'm creating non-static means this variable is going to be created the number of time you create the object of this,
Okay, okay. So
right?
you want to create only once.
Yeah, so the use of this is to make a locking only, right? This variable is not going to be used by this object, the object of this class, right? So it's better always make this as a private also. So private means from outside the class, no one can access this variable, right? And it is always better to make this as static so that this variable is going to be created only once.
So yeah, normally like in this case, the book my show is going to create only once. No? It will
See,
not for
not only one. Suppose from your UI, suppose from your UI, one person booked the ticket. Then book my show instance is created once. Another person call this method, right? So it's kind of a console application. But if you are working with any kind of a web application, then this object is going to be created many number of times. Na? Each time
yes,
you
like
create,
how many clients are there? That many
no,
instances will.
yeah, not clients, but you can say number of users. Suppose you are hosting your application, anyone can book your ticket. So you are one user. You can book a movie ticket by using Book My Show. I can book movie ticket using Book My Show. For you, he is going to create an instance of a Book My Show. For me, he is going to create another instance of a Book My Show, right?
So
So you can
for each user, there will be one instance of book my show will
exactly
be created.
every time you invoke the controller action method, right? I'm talking about MVC application. Every time you invoke one method, the controller action method is going to be there. Every time the method, see, if this method, right? If I'm invoking this method, so currently I'm creating this one, book my show, right? So even I can also do the same thing again. Here also, book my show 2. I'm creating a different instance. Book my show 2, book my show 2, book my show 2. So here I'm making T2 or T4, right? T5, T6. So that is also possible, right? In this case, the number of available tickets, we have hard coded this, right? But in real time, it will be coming from the database only, right? Clear or not?
Okay, so in one instance created, n number of threads can be operated. Is it?
Sorry?
So like thread will not going to create each instance every time, but it is the user rather One thread means one user, or how user and threads are different, or they are same? I just.
So there is no relation between user and a thread, right? So for a single user, you can create multiple threads, right? There is no issue. So for example, if in this case, in previous example, what we have discussed, now inside the main method, we are creating three different threads and three different threads invoking three different methods. Yes or no? That means in that case, one user calling your main method, that for particular that user, you are creating three different threads. So there is no relation between the user and the thread. Don't confuse with the user and the thread. Don't take that user concept into here, right? So basically, this is the threading concept, right? To improve the performance, we are using threading, right? And why we are using threading means we want to execute some methods or some code simultaneously, right? And there is no relation between your user and the thread, right? So did I talk anything related to user? No, I'm not talking anything related to user. See, once you start discussing, once you understand the web application, then you will understand how the web application is working, right? How the suppose the same application, same method is going to be invoked by you, same method is going to be invoked by me, right? That is the different concept altogether when you are developing web application. But behind the scene, the code is going to be like this, right? So in this case, I'm creating, in this case, I have created these things, right? I've hard coded these things, but in real time, this should not be thread one, thread two, and thread three, right? It should be one person come. For that person, one thread is going to be created, and that thread is going to invoke this method, right? And second person, for the second person, the code is going to be same, but the instance is going to be different, right? So that you cannot understand right now until and unless you are not understanding the concept of a web application. How web application works, that is important. Once you understand that concept, then you will understand this, right? But behind the scene, this is the thing that you need to understand. Are you a
Yes,
fresher or are you having any experience?
uh, experience, but not in .NET.
Okay, the same thing. Suppose you are
Yeah.
experienced in any web application, which technology you are working on. So far?
It's a Microsoft technology only. You heard of this Dynamics CRM?
No.
Yeah, so it's a built-in application. So I'm working on it.
Okay.
Yeah, little bit of C# concepts I know, but not in like
Yeah,
advanced.
so that is what I'm saying now. So once you understand the web application, right? MVC application, web form application, or ASP.NET Core web application, web API application, then you will understand this concept clearly. How the web application work, that is important, right? So until because so user concept comes into picture when you are developing any kind of web application. So in this case, this is a console application, right? Console application means wherever you install this application, there you can use this one.
Okay, so threading will only belong to one instance created. Like suppose one instance created. In
No.
that instance, we are trying to
So
do.
why you are confusing with threading with the instance? First of all, tell me what instance you are talking about.
So here in this case, actually, book my show is the one class, and you are creating one instance for it, and for one instance, three threads are there
Yes.
to access.
See, why I'm creating one instance and accessing this. The reason is in this case, this 3.1 T2 3D for this book my show instance, I'm using this variable, right? Available tickets. This variable value is hard coded, but in real time, you will not hard coded the value like this. In this case, if I'm creating three different instances, for each instance, this value is going to be 3, right? So in this case,
Yeah. Okay.
if I uncomment this, right? If I uncomment this and if I invoke this T4, T5, and T6, right? T4, T5, and T6. So in this case, for the second bookmyshow instance, again this variable value will be 3. For this first variable instance, this variable value is going to be 3, right? But in real-time scenario, it should not be the case like this. In real-time scenario, this value, what I'm hard coding it here, it will get from the database only, right? And for that purpose, I'm just creating 3 different threads, right? So in that, but in real time scenario, you will only have one thread, and you will only have this possible, right? And each time your application run, right, one instance will be created, but the value, right, but the value is going to be come from the database. And that value, if multiple application, right, then in that case you will see that this code is this code block is protected. So multiple application cannot access this, multiple user cannot access this code block, right? Before accessing the updated value, it will get from the database. Here I'm updating the value here, but after this you need to update the same value in the database, right? Each time your lock block is going to be execute, it needs to get the data from the database and update the data.
Okay.
Right. So once we start, until and unless we are not starting the database concept, right, ADO.NET or Entity Framework, and as long as the web application concept, what I can suggest you try to learn some web application framework like ASP.NET MVC, ASP.NET Web API, or ASP.NET Core, or ASP.NET Core MVC. Then you will understand this concept very clearly. But for now, this is the advanced concept, right? So you just need to understand in this way only, right? Suppose you are some shared resources, then you need to how to protect the shared resources. You don't want to execute this shared resources by multiple threads, then put this code inside the lock object, right? The lock object is not the only one. Other options are also available that we are going to discuss from tomorrow onwards, right? Right. So apart from log, you can use monitor, mutex, semaphore slim. All these sections we are going to discuss from tomorrow onwards. Now the question is, why do we need to use thread synchronization? Basically for two purposes. One is atomicity, another one is ordering, right? Thread synchronization support atomicity, which ensures that multiple threads in the application are not allowed to access a shared resource concurrently to prevent data inconsistency, right? The code section of our program which causes data inconsistency is known as a critical section. The critical section of our program is executed atomically by one and only one thread, which ensure atomicity. The ticket booking example is an example of atomicity. Ordering, we generally want two or more threads to perform a task in a particular order, and or we want to restrict access to shared resource to a particular number of threads only, right? So it is also possible that you declare some shared resources, right, and you want that maximum 2 threads or maximum 3 threads can access the that critical section. That is also possible. We are going to discuss that things in our coming section. So that is also possible that usually we do not have much control over this, which is the one reason for race condition, right? If multiple threads trying to execute the same code, right? The first example what we discussed, right, where we are not getting the data in the we are not getting the output in a proper manner because there is a race between multiple threads, right? Who is going to execute first, who is going to execute second? There is a race condition between multiple threads, right? Because of that, the output or the behavior is going to be varied, right? And thread synchronization provides one ordering for that, right? So that you can have a proper output in a proper format or proper order, right? The example that we discussed in the past, that is nothing but an example of ordering, right? So you will get the output in a proper order, and atomicity means data inconsistency you can prevent, right? There is no data loss, right? There should not be any wrong data entered into your database, that you can also manage using thread synchronization. There are two types of log. We have seen, and this is nothing but one log.
So this is nothing but we are making a log object. So we are logging this code. So there are actually two types of log. One is exclusive log and another one is non-exclusive log, right? An exclusive log makes sure that only one thread can gain access or enter a critical section at any given point of time, right? In C#, we can implement exclusive log using the log keyword monitor class, mutex class, pinlog class. What is non-exclusive? That means what we have discussed. This is nothing but an example of an exclusive log. Exclusive log makes sure that only one thread can enter and access the log code, right? The critical section code can only be accessed by a single thread. Non-exclusive log means it provides read-only access to a shared resource and limit concurrency. That is the limit of concurrent access to a shared resource. We'll discuss this thing in detail, right? Suppose you are having one shared resource and you want that or you want to give only the read-only access, right? In this case, what is our resource? This is our resource, available tickets. And here we are not only providing read-only access, but we are also providing write-only access. Write-only access means we are also updating the data, right? The problem occurred when we are updating the data. But if we are only providing access, you just read the data and show the output, right? Then in that case, we need to go for non-exclusive logs, right? That we are also going to discuss. The concept called semaphore, slim, right? Reader, writer, log, slim classes, all are used for exclusive, non-exclusive log, right? So the what we have showing here, right? All are going to be discussed in our coming session. So we are going to discuss today. I have shown you the use of log object. Even I'm also going to show you the use of a monitor, mutex, right? Semaphore, slim, read, writer, log, slim, spin log. All these classes we are going to discuss in our coming session, right? So that's it for today. Anybody having any question, they can ask me now.
So normally, like, how many threads can execute simultaneously? Like, is there any restriction, or it is?
See, there are two types of thread. One is a exclusive and another is non-exclusive. Guys, give me 1 minute. So as I told you, how many types of locking is there? One is exclusive lock, another one is non-exclusive lock. Exclusive lock means only one thread can execute the critical section. Non-exclusive lock means you can limit the number of threads to access the code block, right? It is under the control you. If you want that 2 threads, if you want that 5 threads, if you want 10 threads to access the code block, right? Then it's you can decide, right? So if you are using exclusive lock means only one. Non-exclusive lock means one or more threads that you can limit. How many threads can concurrent access a shared resource? You can limit that. Is that clear? How that we will see once we discuss semaphore, slim, reader, writer, log, slim. Then I will show you how to use these classes to limit the number of threads to execute your critical section code.
I didn't mean like to core sections. In general, how many? Suppose we have a database and we have some update job. How many threads simultaneously can run through it? Will that also related to this log only, or?
See the number of threads. There are number of threads you can limit from here, right? Limit from here means you can limit that 5 threads or 10 threads. That's you can limit now. So what exactly? I don't understand what is exactly your question. You want to limit the number of threads to be executed by inside the SQL Server database or inside your C# code?
Inside C# code.
C# code you can limit now. You can limit the limit means in the sense what? It,
No, I don't want to limit, sir. Like, what can be the maximum possible threads at
there
a
is
given?
there is no maximum possible. Either one thread, if you are using exclusive lock, non-exclusive lock means you have to specify. It is mandatory to specify the number of a thread. There is no minimum or no maximum. You have to provide one number, and that many number of threads are going to be executed simultaneously.
Okay, suppose if suppose for example, if I'm taking 1 lakh records to be updated, then how many of threads will be, suppose we are doing it using the thread class, how many of threads will be start simultaneously? All the 1 lakh records will start 1 lakh threads simultaneously, or it will take like OS will restrict some of them?
That basically decided by the OS, right? That basically not only decided by the OS, that will basically depend upon the core and the processor on your machine has, right? So it's not possible that if you are having a single core processor, then you cannot implement this multi-threading. Multi-threading means more than one processor should be there, right? So that basically decided by the operating system. The number of threads to execute simultaneously. See, creating now 1000 thread, it's like a one-to-one, right? So if you are creating 1000 thread means these threads are going to be executed, created one by one, right? And once you invoke the start method, then only the operating system will decide 1 lakh thread, in the sense they are not going to be executed at the same time. One thread execute, then another thread, then another thread. Like this, the 1 lakh thread is going to be executed. Multi-threading doesn't mean all the 1 lakh thread or 10 thread or 5 thread or 2 thread are going to execute at the same time. It is not at the same time. It is going to be simultaneously. Operating system will allocate some time period to T1 thread, and within that time period, T1 thread not completed, it will make that T1 to be idle, and it will start executing the T2 thread. Right, like this, 1 lakh thread is going to be executed.
Okay, thank you.
Right. So it's not like if you are creating 1 lakh means 1 lakh thread are going to be executed at the same time. Same time and simultaneously, both are two different tasks, right? Multi-threading not working on the same time, it is working on simultaneously. Simultaneously means it will execute only one thread at any given point of time, but they are not restricting that that the thread is going to be completed, then other thread is going to execute, right? Some time period will allocate to T1 thread, some time period allocate to T2 thread, some time period allocate to T3 threads, like this, right? Okay. Any question from anyone else?
No question, sir.
Okay. Okay, that's it for today. Again, I will update you, right, at the evening whether we have class tomorrow or not, right? So I will update you. Until 12, we are going like this, right? After 12, we will continue our regular sessions, right? And mostly, I'm also going to take the classes on Saturday and Sundays, because we need to complete the course in 5 months. So we have to keep some extra time.
So it's a class tomorrow, sir?
That I will update at the evening now. That is what I'm saying. Today evening, I will update whether we have class tomorrow or not.
Okay.
Okay. So basically, I'm going outside now. So I'm traveling. Currently, I'm Visakhapatnam, right? So today we are having some planning to visit some places, right? If I'm able to get some time to prepare the documents today, then I will take the class tomorrow, right? Otherwise, I will update the same.
Okay.
So it's a 12 from 12 October.
Yeah, it will going on like this to 12 October, because I'm on vacation, right? After 12 October, the regular classes, right? So obviously, it's not like that the class is going to be missed completely, right? So we have missed the Friday class, so today I took the class, right? And in the same way, if 1-2 classes are missed, then I will cover up those classes in the weekend,
Okay, sir. No problem, sir.
right?
Okay, sir.
So there should not be any loss to you, because even I have to complete the course syllabus. And coming to the video and all these things, as soon as I got some time, then I will upload the same.
Okay, sir.
Okay, sir.
Thank you everyone.
Thank you.
Thank you.
Thank
you
you,
very
sir.
much.
Good night.